In a small, dimly lit workshop on the outskirts of Detroit, an unassuming engineer hunched over a workbench, surrounded by metal filings, blueprints, and crude prototypes. The year was 1911, the world on the brink of technological upheaval, and armies around the globe were engaged in an arms race where cost, complexity, and industrial prestige often outweighed practicality. Most firearms of the time were expensive, temperamental, and prone to jamming under battlefield conditions, leaving soldiers vulnerable and equipment wasted. This engineer, whose name would one day be whispered in armories and drill halls across America, believed the solution was not more intricate mechanisms or heavier materials, but simplicity itself. With just $20 worth of raw materials, a modest lathe, and his extraordinary understanding of metal and mechanics, he began sketching a weapon that would later become iconic, not because it was flashy, powerful, or technologically advanced, but because it worked flawlessly every time. The first prototypes were rudimentary, almost laughably plain, yet each tested principle of function and reliability. Every spring, trigger, and bolt meticulously designed to perform under stress and neglect. The engineer's guiding philosophy was clear. If a soldier could clean it with a scrap of cloth, operate it in mud, or drop it in snow without failure, then it was worthy of battlefield trust. Colleagues were skeptical. Gunsmiths trained in ornate, complicated mechanisms sneered at the simplicity, dismissing it as naive, dangerous, and beneath the standards of military ordnance. But the engineer pressed on, convinced that a weapon's true genius lay in reliability, not elegance. Night after night, he refined tolerances, tested alloys, and simulated the stresses of combat in miniature. He envisioned a soldier in the trenches, a private under fire, and how a jammed or broken gun could mean life or death. And with each small adjustment, the weapon inched closer to perfection. Industrial challenges loomed large. Factories were geared to produce complex weapons with many moving parts. A $20 gun seemed almost criminally inexpensive, a defiance of conventional business logic. Materials were scarce, tolerances difficult to achieve, and quality control inconsistent. Yet the engineer's designs accounted for all of this. He simplified mechanisms, reduced unnecessary components, and selected metals that could endure heat, moisture, and corrosion without expensive treatment. Every bolt, pin, and spring was tested repeatedly. Prototypes were disassembled and reassembled hundreds of times, fired thousands of rounds under simulated battlefield conditions, and exposed to temperature extremes and grit to ensure consistent performance. By the time the first production batch rolled off the line, what seemed impossibly cheap on paper functioned with a consistency and reliability unmatched by far more expensive weapons. The first field tests were astonishing. Soldiers used the weapon in conditions ranging from sweltering deserts to freezing mountains, under gunpowder residue, mud, sand, and rain. Time and again, the gun fired without misfire, without jam, without complaint. Unlike other weapons, it required minimal maintenance, no exotic oils, and few spare parts. Drill instructors reported that even recruits with minimal training could disassemble, clean, and operate the weapon efficiently, making it ideal for mass deployment. Commanders began to notice not just the practical advantages, but the psychological impact. Soldiers who trusted their weapons fought more confidently, moved more decisively, and endured harsher conditions without hesitation. The $20 gun, born of simplicity and ingenuity, had begun to establish a reputation that would soon become legendary. As production scaled, factories encountered new challenges. Standardization was key. Each gun had to meet strict tolerances, yet be forgiving of minor deviations in assembly. Engineers devised jigs, templates, and inspection methods that allowed mass production without sacrificing the weapon's famed reliability. Workers, initially skeptical of the seemingly crude design, grew to respect the careful balance of simplicity and resilience. The gun was inexpensive, yes, but every component reflected a sophisticated understanding of mechanics, metallurgy, and human factors. A design so elegant in its simplicity that it outperformed competitors many times its cost. The battlefield impact was immediate. Early deployments demonstrated that soldiers armed with this weapon experienced fewer malfunctions, required fewer repairs, and could maintain a steady rate of fire under conditions that destroyed other guns. Reports from training exercises, mock skirmishes, and early combat engagements highlighted a staggering reality. The $20 gun not only worked, it excelled, performing better than weapons costing 10 or 20 times as much. Word of its reliability spread quickly, and soon the Army demanded rapid expansion of production. The engineer, once dismissed as a dreamer, became a pivotal figure in American ordnance, a man whose vision of practicality and durability would reshape the military's approach to weapon design. But even as the Army celebrated this miracle of simplicity, a storm was brewing overseas. Rival nations, unaware of the genius behind the $20 gun, would soon face its devastating reliability in battle, and no one would be prepared for what came next. When the first soldiers carried the $20 gun into actual combat, the difference was immediate, profound, and astonishing. Previous experiences with conventional weapons had instilled both caution and frustration. Rifles that jammed at the worst moment, pistols that misfired under moisture or grit, and mechanisms that failed when soldiers needed them most. But the $20 gun changed the battlefield dynamic entirely. Recruits and seasoned veterans alike discovered that, regardless of rain, mud, dust, or sand, the weapon fired each round with mechanical precision, never hesitating, never faltering. In the chaos of trench warfare, in the heat of desert skirmishes, and on frozen mountainsides, soldiers could depend on their weapon without question, giving them a psychological edge as well as a tactical one. Every successful shot reinforced confidence. Every reliable function emboldened maneuvers, and soon, the $20 gun was not just a tool, but a symbol of trust and survival in the hands of American troops. The first battles revealed the genius behind the engineer's philosophy. Its simplicity, often dismissed as naive, proved to be its greatest strength. Whereas complex weapons required constant maintenance and were prone to errors under duress, the $20 gun's minimalist design minimized points of failure. Soldiers discovered that even after hundreds of rounds, with no cleaning for days, the mechanism continued to operate flawlessly. Commanders began to notice a trend. Units equipped with the weapon suffered fewer malfunctions, maintained higher rates of fire, and could sustain prolonged engagements without downtime. The battlefield became a proving ground for the design, and every skirmish added to its growing legend. Even under extreme conditions, the gun performed beyond expectation. Sandstorms, torrential rains, and mud-slick trenches failed to impede its function. Soldiers carried it through rivers and snowdrifts, dropped it accidentally, and even subjected it to improvised tests during downtime, yet it refused to fail. Field reports highlighted its extraordinary tolerance. No other firearm in the arsenal approached this level of reliability at such a low cost. Engineers who had initially doubted the design marveled at its consistency. Drill instructors emphasized it in training as the model of durability and operational excellence. This reliability was not just mechanical. It influenced morale, decisively impacting combat effectiveness. The gun's impact on tactics became evident within weeks. Units armed with the $20 weapon could engage enemies with confidence, maneuver aggressively without fear of malfunction, and maintain sustained suppressive fire in situations where older firearms would have failed. In ambushes, defensive positions, and rapid assaults, the weapon's consistency became a force multiplier. Commanders adjusted deployment strategies, taking advantage of the predictable performance to execute complex coordinated maneuvers. Reports from the front consistently described situations where the $20 gun's dependability directly influenced mission success, with soldiers citing it as the reason they survived engagements that might otherwise have been disastrous. Enemy forces quickly noticed a change. Opposing troops, accustomed to American units being slowed or hampered by misfires and equipment failures, encountered soldiers whose firearms never faltered. The difference was subtle but decisive. American soldiers maintained continuous fire, executed rapid reloads, and sustained offensive actions with a level of efficiency that disrupted enemy plans. Intelligence reports began to document the phenomenon, noting that even under harsh environmental conditions, American firearms were consistently operational, a stark contrast to the failures experienced by opposing units. The $20 gun had transformed a simple infantry weapon into a psychological and tactical advantage, a silent but unyielding presence on the battlefield. Simultaneously, the engineer continued refining the design, incorporating field feedback into minor adjustments without compromising simplicity or cost. Metallurgical tweaks, tolerances on moving parts, and ergonomic refinements allowed the weapon to be mass-produced quickly and consistently, maintaining its legendary reliability. Factories rolled out the guns at unprecedented rates, meeting the urgent demand of a global war, while maintaining quality standards that rivaled far more expensive and complex weapons. Soldiers in every theater, from the Pacific Islands to the deserts of North Africa, wielded these guns with unwavering confidence, proving that low-cost engineering could redefine the rules of warfare. Yet even as the $20 gun proved unstoppable on the battlefield, the greatest test was still ahead. A series of grueling campaigns that would push its reliability, soldiers' endurance, and ingenuity to the absolute limit, revealing the true genius behind its creation. Behind the battlefield, success of the $20 gun lay a level of engineering mastery that few fully appreciated at the time. The genius was not in flashy technology, intricate mechanisms, or expensive alloys, but in the elegant balance between simplicity, precision, and material science. Every component, from the firing pin to the trigger assembly, was designed to operate within tight tolerances while remaining forgiving to rough handling, environmental extremes, and inexperienced operators. The engineer understood that complexity often created points of failure, especially under the unpredictable conditions of war, and so he stripped the design to its essence, keeping only what was necessary for flawless function. This minimalism was deceptive. While appearing crude at first glance, the gun's internal geometry, metallurgy, and mechanical interactions reflected a deep understanding of forces, wear, and stress distribution that even seasoned firearms designers admired once they examined it closely. The key to its reliability lay in meticulous attention to detail. Springs were tempered to provide consistent tension across thousands of cycles. Pins and bolts were hardened to resist shearing under impact, and the barrel was rifled and treated to endure sustained fire without warping. Each part was designed not only for durability, but for interchangeability, allowing damaged components to be replaced quickly in the field without specialized tools. The manufacturing process, astonishingly efficient for the time, incorporated clever jigs, quality checks, and assembly methods that ensured every unit produced matched the exacting specifications of the prototype. What cost only $20 to produce delivered performance and longevity that rivaled far more expensive firearms, a feat that challenged conventional wisdom in both engineering and military. Procurement. Field testing reinforced the brilliance of these choices. Soldiers could disassemble and reassemble the weapon within seconds, often blindfolded, without misalignment or mechanical failure. It could withstand extreme heat, freezing cold, sand, mud, and repeated drops without compromising function. Even after thousands of rounds, the weapon fired reliably, with only minor maintenance required to maintain peak performance. Each successful test, each battle report confirming reliability, demonstrated the genius of engineering that valued simplicity over novelty, resilience over flashiness, and human factors over complexity. The $20 gun became a symbol of thoughtful design, proving that true innovation was often about subtracting rather than adding, about refining function rather than layering sophistication. The weapon's economic impact was equally remarkable. Its low production cost allowed mass distribution across the army, equipping entire regiments without straining budgets. Unlike competing weapons that required specialized manufacturing and costly materials, the $20 gun could be produced quickly, consistently, and at scale. Factories across the United States adopted the design, with assembly lines optimized for speed, uniformity, and quality control, ensuring that every soldier could carry a weapon as reliable as the engineer intended. The simplicity of its design also meant fewer defective units, reducing waste and saving resources that could be redirected to other critical aspects of the war effort. Strategically, the $20 gun empowered soldiers, changed tactics, and elevated morale. Troops trusted their firearms implicitly, allowing them to focus on maneuver, cover, and offensive action rather than worrying about misfires or mechanical failures. Units equipped with the weapon could sustain longer engagements, execute rapid flanking maneuvers, and hold positions under intense fire, confident that their sidearm would function flawlessly when needed most. Commanders began to plan operations around the reliability of these firearms, integrating their dependability into broader strategic calculations. The weapon was not merely a tool, it was a force multiplier, a quiet but pervasive advantage that reshaped both small unit tactics and large-scale engagements. Even beyond combat, the $20 gun influenced the culture of American engineering and military design. Its success demonstrated that innovation did not require extravagance or excessive complexity. Precision, understanding of materials, attention to human factors, and practical testing could achieve results that far outpaced more complicated designs. Future engineers, designers, and military planners studied the gun as a benchmark in simplicity and effectiveness, acknowledging that its legacy extended well beyond the battlefield. It became a case study in how smart, disciplined design, focused on reliability, efficiency, and usability, could produce revolutionary results from modest resources. Yet even as the genius of its engineering became undeniable, the $20 gun faced its ultimate trial: massive campaigns across multiple continents, where heat, sand, cold, and relentless combat would push every component to the limit, and only true innovation could ensure it survived. As the $20 gun entered theaters of war across the globe, it faced trials unlike anything its engineer could have fully simulated in workshops or laboratories. Soldiers carried it through blistering deserts where sand and heat threatened to seize lesser firearms, across muddy European trenches filled with water and debris, and through frozen mountainsides where metal contracted sharply in sub-zero temperatures. Each environment presented unique challenges. Sand could infiltrate delicate mechanisms, rain could corrode surfaces, and extreme cold could sap the elasticity of springs or freeze lubricants. Yet the $20 gun consistently overcame these obstacles with remarkable reliability, a testament to the engineer's foresight in selecting materials, tolerances, and construction methods that prioritize durability over aesthetics or unnecessary complexity. In every battlefield, it performed as if impervious to the chaos around it, firing round after round with precision and consistency, earning it a reputation as the weapon soldiers could always count on. Combat reports from multiple fronts reinforced its legend. In North Africa, soldiers waded through dunes where sandstorms blinded men and jammed older weapons, yet the $20 gun continued to operate, each shot reaching its target without hesitation. In the Pacific Islands, troopers slogged through mud, rain, and humidity so intense that other firearms rusted or jammed within hours. But the gun's steel components and careful alloy choices resisted corrosion and maintained function. In Europe, the freezing temperatures of winter campaigns challenged lubricants, springs, and metals, causing traditional firearms to fail. Yet the $20 gun fired reliably, its mechanisms calibrated to function even under severe contraction of metal and thickening of oils. Across continents and climates, the gun's performance remained exceptional, earning trust from enlisted men and officers alike. Field maintenance further demonstrated its practicality. Unlike many contemporary firearms that required complex tools, precise cleaning routines, and specialized knowledge, the $20 gun was remarkably forgiving. Soldiers could disassemble, clean, and reassemble it quickly with minimal tools, often under the most adverse conditions. Even after prolonged exposure to grit, water, or neglect, the weapon fired reliably, requiring only routine checks rather than constant repair. This robustness allowed troops to maintain operational readiness, contributing to sustained offensive operations and reducing downtime caused by mechanical failures. Commanders praised the reliability, noting that units equipped with the gun performed consistently better in engagements where environmental conditions would have crippled less resilient weapons. The $20 gun's durability also extended to ammunition and logistics. Its design minimized misfires caused by imperfect cartridges or environmental contaminants, and its simple construction facilitated consistent feeding from magazines or clips under adverse conditions. The combination of mechanical reliability and logistical ease meant that soldiers could rely on the weapon not only to function, but to function continuously, a critical advantage in sustained engagements where supply lines were stretched and maintenance facilities were scarce. The gun became a linchpin of battlefield strategy, enabling aggressive tactics and prolonged operations that would have been impossible with less reliable firearms. The psychological impact on soldiers was profound. Knowing that their weapon would function under virtually any condition boosted morale, confidence, and initiative. Troops were emboldened to take positions under fire, maneuver aggressively, and execute complex tactics with assurance. Anecdotes abounded of soldiers surviving ambushes or prolonged firefights solely because their $20 gun did not fail when others' weapons did. Letters home, military dispatches, and unit reports consistently highlighted the trustworthiness of the gun, not merely as a technical achievement, but as a lifeline in the chaos of war. Even enemy forces began to notice its effect. Opposing troops, accustomed to relying on predictable mechanical failures of standard-issue American weapons, were confounded by the consistent performance of the $20 gun. Ambushes that might have succeeded against malfunctioning rifles failed, Defensive positions held longer, and the tempo of engagements shifted decisively in favor of the American forces. Intelligence officers documented repeated encounters where the reliability of the $20 gun contributed directly to American victories, illustrating how a single well-engineered firearm could influence strategic outcomes across multiple theaters of war. But as the $20 gun proved itself across the globe, a new challenge loomed: mass production, supply demands, and the pressure to equip millions of soldiers would test the ingenuity and resourcefulness of its creators like never before. Once the $20 gun had proven its reliability in harsh combat conditions, the next monumental challenge was scaling production to meet the demands of a global war. Millions of soldiers needed to be equipped quickly, consistently, and without compromising the weapon's legendary durability. Factories across the United States were mobilized, assembly lines expanded, and the principles of efficient manufacturing were pushed to their limits. What could have been a logistical nightmare was transformed into a showcase of engineering foresight. The gun's simple design, minimal parts, and standardized components allowed for rapid mass production while maintaining strict quality control. Engineers devised innovative jigs, templates, and inspection protocols that ensured every gun leaving the factory met the exacting specifications that had made it famous on the battlefield. Even as production ramped up exponentially, the legendary reliability remained intact, a feat almost unheard of for wartime armaments at such scale. The economic efficiency was equally remarkable. At just $20 per unit, the gun could be produced for a fraction of the cost of competing firearms, freeing resources for other critical wartime needs. This affordability allowed the U.S. military to arm not only frontline combat units, but also reserves, allied forces, and support personnel with the same dependable weapon. Factories leveraged mass production techniques that had been refined in automotive and industrial manufacturing, applying assembly line principles to firearms while preserving the precision tolerances necessary for reliability. Workers, initially skeptical of the seemingly simplistic design, quickly recognized the genius of the engineer's approach, as fewer defects, easier assembly, and consistent function made their jobs both more efficient and more meaningful. Field deployment of these mass-produced guns demonstrated that scaling up had not compromised quality. Soldiers across every theater received weapons that functioned identically to the original prototypes. Units in Europe, the Pacific, and North Africa reported consistent performance under extreme conditions: desert heat, jungle humidity, frozen alpine valleys, and muddy trenches. The weapon maintained its mechanical integrity even after repeated disassembly, prolonged use, and exposure to grit, rain, or salt water. This uniform reliability allowed commanders to plan operations with unprecedented confidence, knowing that every soldier would have a dependable firearm capable of performing under any circumstances. The psychological effect was immense. Troops trusted their weapons implicitly, enabling more aggressive maneuvers, sustained engagements, and complex tactical operations that leveraged the gun's dependability as a strategic asset. The mass production effort also showcased the ingenuity and adaptability of American industrial capacity. Factories implemented rigorous quality assurance measures, using testing jigs to fire sample rounds from every batch and employing precision measurement tools to verify tolerances. Even with rapid scaling, the failure rate remained remarkably low, preserving the weapon's reputation for reliability. Logistical chains were optimized to deliver guns to frontline units quickly, while repair depots and field armories stocked replacement components designed for easy maintenance and interchangeability. The engineer's foresight in creating a simple, robust, and modular design paid dividends. Mass production became not a compromise, but a demonstration of scalability without sacrificing excellence. Soldiers in combat began to recognize the strategic impact of widespread distribution. With every unit equipped with the same dependable weapon, coordinated attacks, suppressive fire, and defensive operations became more effective. Training could be standardized, maintenance simplified, and battlefield tactics could assume a baseline level of reliability that was previously impossible with diverse or temperamental firearms. The $20 gun had become more than a tool. It was the backbone of infantry strategy, a silent but decisive factor influencing the outcomes of engagements and campaigns. Commanders could deploy forces knowing that each soldier wielded a weapon that would not fail at critical moments, dramatically increasing operational flexibility and confidence. Even as production peaked, the engineer continued to oversee refinements. Minor improvements in ergonomics, spring metallurgy, and component tolerances were implemented without interrupting the assembly lines. This continuous evolution ensured that newer units maintained compatibility with older ones, while benefiting from incremental enhancements. Soldiers could exchange components in the field seamlessly, minimizing downtime and ensuring that the weapon's legendary reliability persisted throughout its service life. The combination of thoughtful design, robust engineering, and efficient mass production elevated the $20 gun to a symbol of American ingenuity, resilience, and wartime industrial might. Yet even as millions of soldiers were armed with this extraordinary weapon, a shadow loomed. Enemy forces, desperate to understand and counter its reliability, began studying every captured unit, and a new chapter in the $20 gun's legendary story was about to unfold. As the $20 gun dominated battlefields worldwide, enemy forces were forced into a frantic race to understand, replicate, or counter its remarkable reliability. German, Japanese, and other adversary engineers scrutinized captured units with obsessive intensity, dissecting each component, measuring tolerances, analyzing metallurgy, and reverse engineering mechanisms. Yet despite their expertise, they repeatedly failed to reproduce the combination of simplicity, durability, and efficiency that made the original so formidable. Competitors often overcomplicated their designs, added unnecessary mechanisms, or used inferior materials, creating weapons that were expensive, fragile, or prone to failure. The genius of the $20 gun was not simply in the parts, but in the harmony of design, a harmony that could not be duplicated without understanding the subtle insights of its creator. Reports from frontline combat revealed the extent of this advantage. Soldiers armed with the $20 gun faced opponents whose attempts to copy or counter the weapon fell short. Enemy firearms jammed, misfired, or broke under conditions that the American gun handled effortlessly. Ambushes and skirmishes exposed the limitations of the rival designs, often turning the tide of battle decisively in favor of U.S. forces. Intelligence officers noted that even when adversaries produced weapons with superficially similar components, the lack of precise tolerances and the absence of the elegant simplicity inherent in the $20 gun resulted in catastrophic failure rates under real-world conditions. The weapon's superiority became a strategic factor, influencing not just individual engagements but entire campaigns. The psychological impact on enemy troops was profound. Facing a weapon that refused to fail instilled fear and frustration. Soldiers who had trained to exploit mechanical unreliability found themselves contending with American firearms that performed flawlessly under every circumstance. Reports described how units equipped with improvised copies often lost confidence in their weapons during critical moments, while American soldiers, assured of their guns' dependability, executed maneuvers and offensive operations with boldness. The $20 gun had become more than a tool. It was a symbol of superiority, innovation, and the indomitable advantage of thoughtful engineering. Meanwhile, back in the United States, the engineer and his team continued to refine, test, and improve the weapon, ensuring that it remained ahead of any potential countermeasure. Incremental enhancements in metallurgy, component durability, and assembly processes kept production lines ahead of enemy attempts at replication. Feedback from soldiers in every theater informed these refinements, creating a continuous loop of improvement that ensured the gun's performance remained unmatched. By the time adversaries believed they had decoded the design, the American weapon had evolved, maintaining its edge and securing a decisive advantage in combat. The $20 gun's legacy extended beyond its immediate impact on wartime engagements. Its reliability redefined the standards for infantry weapons, demonstrating that careful engineering, simplicity, and practical testing could produce results far beyond what expensive or complex designs could achieve. Military planners incorporated its principles into future firearms development, valuing ease of production, durability under extreme conditions, and operational reliability over flashy innovations or untested technologies. Generations of engineers and soldiers studied the $20 gun as a benchmark, a case study in how innovation could transform not just equipment, but the very outcomes of war. By the war's end, millions of soldiers had carried the weapon into battle, trusting it with their lives under the harshest conditions. Factories across the country had produced tens of millions of units, each one embodying the same principles of simplicity, reliability, and precision that had driven its creation. Enemies had tried to copy it, sabotage it, or render it obsolete, but none succeeded. The $20 gun remained a cornerstone of American military effectiveness, a triumph of ingenuity, practical engineering, and visionary design. It was not merely a tool of war, it was a symbol of what could be achieved when intelligence, creativity, and relentless focus on function converged in perfect harmony. And so, from a small workshop to the battlefields across the world, one engineer's $20 gun changed the course of history, proving that brilliance doesn't have to be expensive, and that the simplest design can sometimes be the most unstoppable force in warfare.